Hi everyone, welcome to Code Kamkaj YouTube channel. I hope everybody are doing good. In the last videos, we had been discussing about MLflow components and use case one by one. Today's video will be discussing about amazing concept called as MLflow project. So what is MLflow project? So MLflow project is a component of MLflow platform that designed to help the data scientists, developers, machine learning engineers, and MLflow engineers to easily manage and reproduce the machine learning projects. So if you go with the simple terms, so MLflow project it's like a blueprint for machine learning project, and it is organize your code like dependencies and setting up in a standard way so anyone can understand and rerun your work in a same environment. So which means like you are going to bundle all your dependencies together, and you are specifying how you can run your source code, all the required settings, and in a specific and standard way. And you're going to give to somebody, like it can be a colleague or it can be someone from the same organization in your other organization, so they will run your code and they will expect the same results in their environment, or it can be a same environment. So that's the use case of MLflow project, which means like you're going to bind everything of your entire MLflow, machine learning project by help of MLflow. So we have a different shapes of packaging, we can say that, or we can go with a different terminology also, like binding together all your dependencies. So we have the different ways of binding, like you can use conda.yaml file, or you can use the like MLflow file to bind all your dependencies, and you can expose all the related information. And today's video will discussing about how can we ship or how can we package our entire source code to somebody by taking help of Docker. So we'll discuss about like what is the Docker file and how we can create a Docker image, and how we can run the entire source code by help of MLflow UI, and how we can see the all the source code metrics on MLflow UI by exposing into the 5000 port. And we'll see about all those things in this video. So the main use case of MLflow project, that if you have a source code and you would like to give a source code to somebody, so you need to make entire source code as a package that it doesn't lose any dependencies. Which means like if you have a share your source code to somebody, and they may not get trouble like hey, I don't have these dependencies, so which kind of version do I need to use? So to resolve such issues, like MLflow brought this concept called as MLflow project, which means like you're binding all together dependencies, all your source code on all the commands that is required to run on other environment. So that's the beauty of MLflow. So now let's deep dive into the implementation. I'll walk you through the code, and I'll walk you through all the dependencies, how we can use MLflow project component, and how we can ship interior source code. So let's go. So here I have you can ignore the other directories and files that have reflecting over here, but you can focus on this directory, like which have the Docker and Docker file registry, and requirement.txt and supervise.conf. So first I'll walk you through the registry register.py. So this is my application of my machine learning. So where it has a load the data and it trained and registered my model into one of the MLflow registry. So I have been using the same code, like it hasn't been changed for previous video and this video. I've been using the same code. I haven't changed even a single line. But the only thing that I'm going to change that, and I have added few files that I would like to ship to someone as a packaged entire source code. So this is my entire source code. Like it hasn't been changed anything, and it has all the related code related to logging your model, like logs and who has created descriptions, and iteratives of versions and everything that has been added into the source code. And so this is what about your machine learning code that we have interacting with MLflow UI by respected IP address. So this is the 127.0.1 dot colon sorry 1 colon 5000, which is my local host at the 5000 port. And this is my experiment name, and this is my registry name, and like I have been giving the model path, everything. Fine. So this video, we're not going jump directly deep into the source code, what we have done, but those sessions was already completed in the last videos. So this session is repeatedly only for MLflow project. So as I said, if you would like to package into your source code, and we have the different shapes, you can use a conda.yaml, and you can go with the other shapes, other way of packaging your source code. But in this video, we'll discuss about entire our source code going to be dockerized into your Docker file, and later we'll create a Docker image out of the Docker file. So yeah, first, I have all my source code, all my libraries has been imported here, and I have requirement.txt. So if you would like to run the same source code into any other environment, so I can take advantage of this requirement.txt with a single go. I can install all the dependencies, and this is about requirement.txt. And the next beautiful thing is that superworld.conf. So this is the file, for process management, that it help to manage and control the process like operating system, and mostly we use this file that related task. So supervisor run in the background, and it can automatically start and stop and restart the particular program. Like in our case, it's MLflow. So if you would like to start or stop our MLflow program dynamically, so we can take advantage of this supervisor conf dot file, and we can run our MLflow our MLflow server in the back end, how many times it has to be run, and we can run a number of times all our models, its prediction getting logged into our MLflow server. Fine. So if you take example of we have the program section, which is a program colon MLflow, and before that we have the node.am is equal to true. So this is the settings, it tells supervisor to run in the foreground instead of a background as a daemon process. And the second section, we have the program colon MLflow section. So here we have the first section called as a command. This is the command. It starts the MLflow EOA on the host, like in a local host. It can be any other host if you are going with a productionized. But in my case, I've used the local host, and making it the IP address, which is a 0.0.0, and the port number is 5000. So the MLflow tool is going to be entire managed end to end. So that's why, and I have been using this is for tracking purpose of my all metrics. So that's why I have been hosted this respected MLflow server on localhost. And the next one is autostat is equal to true. So this tells supervisor to automatically start the program whenever it starts. And when you start the supervisor, it will automatically start the MLflow UI. The next one is auto restart is equal to true. So this component, they ensure that if MLflow UI crashes or any happen, which is or exist any unexpectedly, so supervisor will automatically restart it, which means it will automatically restart our MLflow UI. So that's all about the program MLflow. And the next one is program colon training section. So we have the command is equal to Python register.py. This command runs the respected or Python file, in our case, which is register.py, and this could be customized training or registration script we can use for processes of data and register the model or perform the other setup task in MLflow. And the next one is autostat true. So autostart true tell the supervisor to start the register.py and automatically whenever a supervisor start. And the next one is auto start is equal to false. So this indicates that if register.py finishes its execution, so supervisor will not restart it. This is like because of register.py is intended to be run in one time setup. So if you have a requirement, if you'd like to run all your register.py in multiple times, keep going on each every individual of time, you can customize this like an auto starts as a true. So if you make it as a true, it will run all your register.py code into every second, and you can customize it, how many intervals you would like to take and how many times it has to be run in each intervals. So that's up to your customization, how you would like to make it. So yeah, so that's all about the supervisor d.conf related. The next one is amazing thing that here we have is a Docker file. So this is the Docker file, and I have been taking a few Docker components and I have written this Docker file. So if you're not familiar with the Docker file, I already made few videos in Docker file. I request you to go and watch those videos. So yeah, I brought few components, like these components are necessary to write your Docker file and create the Docker image, and this is predefined from the Docker itself, so you don't have other chance to customize it as per your intended. So I've taken the Slim as a base operating system as image, and my work directory is app. So I'm copying all my requirement.txt from here, this directory, and I'm running the pip install, requirement.txt, which means like whenever the image creates. So I have been I've been installing all my requirement.txt dependencies, and later I'm copying all the required files, such as my supervisor d.conf and registrar.py, and later run that whenever you are creating a container. So this command will run, like, and it get updated, and it will install all the dependencies like supervisor, and which will going to be listed over into var lib aptl list. And later, it's going to copy the configuration file, such as supervisor.conf and respected location called etc and supervisor.conf.d and respected place. And it has been exposed with the port number such as a 5000. And the cmd, while you're creating the container, so this command execute, and along with your source code, and this is how my register.py file get called from this supervisor.conf, and it get executed. So yeah, that's all about my all Docker file information. Now we are going to execute few commands that, while I'm interacting directly with a Docker, and I can create the Docker image out of my Docker file, and later we'll run that Docker image to create a container, and that container will expose with a 5000, and in that 5000 port we'll see the MLflow UI, and we'll see the all the metrics. So yeah, let's go. Yeah, we have the Docker file, and we are in the same directory path, which is a MLflow Docker. This is my Docker as a directory. So yeah, so if you would like to create a Docker image out of a Docker file, so there are a few commands that we need to use it. So the command name is Docker. Sorry, capital Docker build -t, and I'm going to give my image name as a my underscore first underscore image, and sorry, it should be underscore, and I'm going to give a dot. So this is the command, you're going to build the Docker image out of your Docker file wherever it is in root level. So once I press enter, it will build my image from my Docker file. It will call all my source code, it get copied into my image, and yeah, that will execute it. So I already installed my Docker desktop. So to see whether the image is available or not, or I can go and see the in UA level itself all the logs, whether my content is exposed or not. So that information I can see in my Docker desktop. So if you haven't installed Docker desktop, so already made a video on installing a Docker desktop and enabling Kubernetes on top of it. So I request you to go and watch the video. So seems to it is going to take some time. So what I will do, I'll pause the video and come back. Okay, fine. So Docker image has been created. So what I will do, I'll go to my Docker desktop, and I'll find my image name. So this is my image name. I'm copying this, my first image. I'll go to Docker desktop. So I'll go to image session here, and I'll search with my image name. So here, this is my image name, and it has been unused. And this is 827 MB, guys. So yeah, so it is too big. We'll discuss about how to reduce the image size in the upcoming session. Fine. So we have the Docker image, we can see what all layers and what all packages we have inside. All the information you can see inside of this Docker desktop, and you can take advantage of it, and you can export it in your own go. So now our requirement is to create a Docker container. So since we have already created a Docker file, so you can share this Docker file to a number of your people inside of your colleagues or your team members, and you can tell them to run the Docker container. So they will expect the same results whatever you have seen in your local, that you have discussed in the yesterday session. Now, so yeah, now we are going to create the Docker container out of the Docker image. So the command is docker run hyphen p is a port number, so we are going to expose it to the 5000 port with a port forwarding, and the image name, so we need to provide the image name. So if I click enter, so my Docker container will start, and if you see, it has been getting logging all the logs here. And if I go back, if I go to container session, I will see my image name. This is my first image, and this is the name of the container, which has dynamically updated. But you can see this is the container ID. And if I go to this, if I drag this, oh, come on, yeah. So if I click on this, it will redirect me to the my browser, and now I can see this. This is the MLflow has been running on, and if I go to my first test experiment, so this is where my experiment has been logged. So it just has created 37 seconds ago, which means it has been 37 seconds that we have ran the entire our Docker container. So that's why it is showing like this. And if I click on this, I can see all the information that we have seen in our local, where we ran on our local machine. So now this entire application is running on my container. So if you would like to share your entire machine learning project to your colleague, so this is how you can share it to somebody as an image, and they can run the image into their local, or they can run on any Kubernetes cluster or anywhere, and they can see the same metrics whatever you have seen in your local. So model metrics, system metrics, and we have the artifact session. And if I go top level, we have the model. This is the model registry, and we have the version one. And if I click on this version one, I can see all the information about who has created and what is the data set and what is the framework that we have used. So this is how you can share to your colleague or someone by taking advantage of MLflow project packaging. Fine. So yeah, this is all about the MLflow project. That's I'd like to share to you. So I request you to get a good understanding of Docker and Docker components, and um, supervisor d.config file, why we need to use it. So accordingly, we can ship your entire source code. There are a bunch of ways. It's not the only way that you can use the MLflow project as take advantage. There are a bunch of ways, you can ship entire source code to somebody. But yeah, I just brought some real world best example to showcase in this MLflow project concept. So yeah, I hope it is clear for everybody. So now my container is running on. If I go to this my Docker desktop, so if I click on my container, I can see the logs. So if I go on the inside of this container, I can see the logs. So this is how my logs get executed. And if you see this one, it has been executed. If I want to inspect, I can inspect it. If I want to do exec, I would like to jump inside of the container. I can see I can do ls. We have the Docker file. This is where registry.py and requirement.txt supervisor.config file. All the things has been copied inside of my container. So if I do cat, I don't know whether cat will work or not. Let's see. Docker file. So yeah, now I'm instead of containers. If you see this one, so this has been matching with our actual Docker file that we have written here, which is similar, which it got copied, and that is how it has been executed. And if I do clear, if I do ls, if I do cat of my registry.py, sorry, rdis register.py. So this is my source code that has been used as a register.py, and this is all the information about my train the model, and logging all my model and registering with the model name. And this is the my first model registry and description, who has created, and all the client information, and even the URL of your MLflow. So you can see all the information that are available inside of my Docker container. And what else? So federal so we have the supervisor.conf, uh, cat sup or viso audi dot conf. So this is the file that we have written to maintain our server continuity, and how many times you'd like to execute the code and all, and what is the IP address and what is the port number that we have seen. So this is how you can do jump into the Docker container inside. You can log inside of it, and you can see how many files has been copied inside, and you can play around it, and you'll get good hands-on on this, like MLflow project and Docker related information. So yeah, now it has been running on. If I go to logs, so I'll see all the logs over here, and what is the timing that it has been executed and all. And now I'm going to stop my Docker container, and now it has been getting running on my port number 5000. So if I get stopped it, you can stop it from here, from ML, this one Docker desktop, or you can stop it from CLI because it has been running on. So what I will do, like I'll stop it from here itself. If I do stop, my CLI will be get off, and it has been terminated. And if I go and refresh this page, it won't be reflect here because the content is no longer running on my background. So that's the reason you cannot see any errors here. And if I rerun the same command, like in docker run -p with that, I can see that, like another experiment got run. Sorry, another run got run under the experiment. So if I go here, my first test experiment is the experiment name. If I see this one, we have the 5 seconds ago, the same run has been run with the metrics, like who has created all the registry information. So this is how, like you can share this image to a number of people across your organization. They will run your uh, image as a container, and they will expect the same results. Fine. So yeah, I hope it is clear for everybody about the MLSOR project. And if you have any questions, feel free to drop your questions in this comment section. Thanks for watching. Share this video to your friends and family members who would like to learn the MLOps and other upcoming technologies. Until then, bye bye.